Hi, and welcome back to the series on harnessing large language models in healthcare. Today we're going to be looking at prompt engineering. If there's one thing that I want you to take away from everything, is understanding that prompt engineering is where it is worth your time, energy, and effort to invest a lot of energy. So, what is prompt engineering? Prompt engineering is using natural language to uh, program, if you will, the large language model to create an output that is useful and meaningful for you. So when we think about where you are now, we're going to assume that you are just coming in with your current knowledge. We're going to start trying to define some more specific so that you can start identifying where your needs are. You're going to learn some different techniques that I'm going to go over. And then I'm going to try and have you practice some of those skills and those techniques. And by the end of this, I am hoping that you're going to walk out with some really effective prompt engineering techniques and processes that will allow you to be a master at prompt engineering. So, what is prompt engineering? Why do we care? How does it matter? All it is leveraging natural language to have a large language model and its perceptrons and AI output something that is useful for you. So there are different techniques. Some of them involve a variety of language, and some of them are more basic than that. We're going to talk about a little bit how LLMs are evolving. We are often seeing situations where we will take whatever prompt that you've given, we will apply some prompt engineering over top of it to try and guesstimate exactly what you're trying to get, and uh, run that through the system instead of just what you type out. And we're going to talk about different prompt methods, zero shot, few shot, a little bit about RAG, context window, all of those specific things. One thing that I will want to just highlight for you is even as the systems evolve, even as the systems get better at what they do, the more you understand about prompt engineering, the more results that you can get out of it on the other side. If you think about the people that you know that are able to Google very, very effectively, most of them have some deeper knowledge of the ability to uh, get it down to specific dates or specific websites. And they are able to leverage some of the tools that Google provides that are something you have to learn and be taught rather than something that you're just going to intuit by typing in a search. So, when we think about a prompt, there are different pieces of a prompt that you want to think about. In general, you're going to want to, because this is in a professional setting, you're going to want to provide it a role or a persona, something that is going to help guide it, that you don't want it to be talking like a general redditor. You don't want it to be talking like a PubMed research paper. Essentially, all of the open source research papers feature strongly in the training of these models. And so it can be very easy if we're using specific healthcare terminology to wind up where it's trying to do an academic paper. And so by being very specific, you can start to help the prompt know what you're looking for on the other side. Then you want to go in and you want to give it a context. You want to give it some type of background to frame the prompt appropriately. Sometimes you want to give it extra information. This context is often where we stick things like the retrieval augmented generation, RAG, that you'll hear about. And then finally, they're going to be your specific request, and you're going to want to outline the task or question to be addressed. What's zero shot versus few shot? A zero shot, you just make a request of the system. You don't give it any examples. A few shot, you start giving it examples of what you're looking for on the other side. A large language model, if you give it examples, is going to be very good at expanding on those examples and growing those examples. If you are not finding a large language model is delivering what you're wanting, you're probably not giving it sufficient examples. The examples also help it just grasp what kind of format and tone that you're interested in. These were the predominant techniques for many years. They still are very functional, very useful. Um, for a little while, probably about a year, chain of thought prompting became very popular in large language model circles. In that chain of chain of thought prompting, you would tell a large language model, I want you to think this through. I want you to talk about all of this, create a step-by-step reasoning, uh, identifying any intermediate steps that are wrong, how to improve the logic flow, and then on the other, at the end of all of this, it would spit out its answer. So with chain of thought prompting, you would be able to have it accurately count the number of R's in strawberry. If you've not heard of that, many large language models, if you go back to ChatGPT 4, it can't count the number of R's in strawberry. Remember when we talked about large language models in our earlier lectures, we talked about how things are broken out into tokens. It's not actually seeing the word itself, it's seeing a numerical representation in vector space. And so these systems have to have some additional help. Chain of thought prompting uh, at a high level, if you want to think about chain of thought prompting, what you were doing was taking your existing prompt, having it talk through all of the different pieces of information it has in its memory about how it might answer that prompt. And then because it's continuing to iterate over the next token, it will have had all of that information that is scattered around its entire database, kind of all centralized in one place, and then be responding just to that information instead. That proved to be a very powerful, very useful capability. Chain of thought prompting has lost some of its value with the new thinking models. And they are doing, well, ChatGPT is doing something different with its thinking models. Some of the thinking models out there are just doing chain of thought prompting in the background of the system. Most of them are doing something a little more intelligent with how it does the processing, where it doesn't have to generate the tokens themselves, but it gets to cycle through and choose the best path. When I did testing for O1 versus O1 Pro for ChatGPT, as an example, I found that if I generated something about 6 times, one of those 6 times would be the equivalent of a single O1 Pro generation. O1 Pro, those O1 generations would take about 60 seconds each. O1 Pro would take about 12 minutes. I wouldn't have to go review and try and do additional generations if I did O1 Pro. So if I just wanted to have the best answer that the prompt that I am providing is going to give out, I would just run O1 Pro. I did not find any situation, even when I ran a prompt 20 times and read every word of its output, where O1 generated something that was fundamentally better than O1 Pro. I saw many situations where it generated something a little different, but consistently O1 Pro would just provide the best possible output because of the way they've implemented that background thinking process. It just took longer. And so if I didn't have a strict timeline, I would often choose to use that because I just want the right answer. I don't necessarily want to spend a lot of time on it. So when we're thinking about good prompting principles, I always encourage politeness. And why do I encourage politeness? Because it's trained on both polite and impolite language. And I find that the polite language is often the type of output that I want to see. We want to look at clarity. We want to be very specific in what we want. We want to be purposeful in where we determine that we want to do um, open-ended questions, open-ended instructions, and where we're close-ended and specific about what we want. We need to be very specific, and we need to make sure that it has the context to be able to accomplish and do what we're trying. So all of this necessary background details, for example. This is just a quick example. You're a clinical assistant. A context might say the lab results, you're reviewing lab results for suspected anemia, and we're going to summarize these key lab metrics and evaluate. All of those start giving us pieces and parts of the prompt. So if we're thinking about the pitfalls of poor prompts, we want to make sure that we are avoiding vague instructions. We want to make sure that we've reread our prompt to make sure that there's no overly broad, potentially uh, things that are going to contradict with each other. And we were going to want to be very specific in the expected format, what type of output that we're going to provide. I was working with a friend the other day who wanted to generate PowerPoints, and they were working with GPT 4.0, and it kept telling them that it was only about 5 minutes away from having generated the PowerPoint for them. It turned out in their very first prompt, it misunderstood something, and so it thought that it was supposed to lie to the end user and tell it that it's only a few minutes away from generating a PowerPoint. All the while, it wasn't doing anything. And it gave us a bit of a laugh when it finally was something that we realized. We realized it because we switched it to a thinking model, and the thinking model thought about how it had to lie to the end user. So there are opportunities for systems to make mistakes. So this is the part where we'll either do a live demo or most likely we're going to jump into hands-on exercises. I'm going to split everyone into 5 groups with boards, and I'm going to give them a specific um, prompt that I want them to build. And then I'm going to let them share their outcomes after 10 minutes and what they're doing to try and accomplish these things. And then, because I think it'll be fun, I'm going to show them how we're going to build uh, these prompts in a very effective way. And that very effective way is we go onto ChatGPT's website where they've got a 8-page document on effective prompt engineering techniques. We copy and paste that into our context window, and we drop in a 1 to 2 sentence summary of here's what I want to have a prompt built for. And then we say, here's the context of what it takes to build a good prompt. And it will build a very good prompt for you. I do find that it behaves better than if I just go in and I say, I want you to act as an expert prompt engineer. That tends to get you 80% of the way there. But if I drop in the full context of uh, a large language model vendor who is, very good, and took a lot of time to actually build this documentation, it will just generate fantastic prompts. When the deep research module was released, I went to the announcement where it taught you how to build those prompts, and I copied and pasted that entire web-based site, dropped it into a chat, and then told it to um, build the prompts for deep research based off of that. It's not that I'm lazy. It's just that I really want to be efficient in my use of time. All right, sorry about that quick pause. You should see on the screen a ChatGPT prompt. And so in this case, I copied and pasted everything about deep research. And here said, I'm a biomedical informatician about a few different things. And I just wanted to give me some ideas of things that I could do deep research on. And once you get to the bottom of that, it gave me 25 different ideas. I said, okay, great. And then please create a deep research prompt that would explore data visualization in biomedicine. And it then creates a prompt where it um, has a very nice job of building it out in such a way that deep research doesn't have a lot of questions. So, example, it's specific in its data collection. We want PubMed, we want ACM. It's specific in its analysis steps. It's specific in the report that we want in the final output. I deleted this. I'm assuming it's using October 1st as the cutoff because that's when its knowledge cutoff is. Because deep research actually goes out to the web, and we don't need to have knowledge cutoffs like that built into the system. But yeah, go through and give scope, key areas to address. All of these things just made my ability to query deep research very, very simple. And leveraging those same uh, copy and paste ability with the notes is just powerful and something that you should absolutely use. It'll help you build prompts very quickly. And with that, thank you so much for tuning in, and I'll catch you on the next lecture, which, as I'm thinking about it, well, actually, since we're online, I'm going to give you a few more slides that I think will just be helpful. Uh, when we think about prompt engineering, this is for policy or research. We want to summarize new research papers succinctly. We can generate policy briefs very rapidly. But we also need to keep in mind that unless it's going out to the web, we won't know if the knowledge is current. For clinical prompts, we want to define scopes. We want to focus on only medical interactions in particular, as an example. We want to make sure that relevant patient history is included. We want to make sure that we're looking for some type of validation. So those examples in the few shot prompts where we're looking for outputs against real data. Often with prompt engineering, we make mistakes where we overload the prompt with unnecessary details. So the longer the prompt, the more likely that is to go off into the weeds. You might question. So I did a test a while ago. It is 100% possible for where I said we're going to have that ChatGPT website we just copy and paste and all its text. It's 100% possible to take that, summarize that, into about one page of text, and it accomplishes the same goal. I didn't save that off, and so I just always go back to the website, and it functions well enough. It functions better if you summarize it down to one page so that it's just getting that core meat of the capability. Because otherwise it does overload it and it does tend to have it wander a little bit more. It's just there's a significant difference between me futzing around with large language models and doing this in a professional setting. In a professional setting, you are going to want to be concise and specific. Um, Make sure that you're not ignoring the model context size. That's becoming less and less of a problem in modern eras. But for a long time, it was 8,000 tokens or it was 4,000 tokens. With 100,000 tokens, it's becoming a lot easier. But that doesn't always apply if you're not allocating enough RAM resources. So my home GPU RAM is about 30 gigabytes, and if I run a 32 billion context large language model, it can only handle about 16 to 22,000 tokens, depending on the model. And so even though the model itself can handle 128,000, I just don't have enough GPU RAM to be able to handle that much. And keep in mind that you can't always expect it to be able to perform multi-step logic without full guidance. When you're thinking about prompt versioning, make sure you start simply and refine it iteratively. Retest uh, after every model update. Models, because of the training that we put them through and how we rebias them, can dramatically change the type of output that they do. And so you have to just test it and make sure that it's still functioning. No matter how specific the prompt, no matter how good the prompt is, sometimes things break that they never would have predicted would break if it's outside of what they are specifically testing. And then just think about ethical prompting. There are going to be re-identification risks if you expose large language models that have access to your internal resources. They can do some great work in aggregating and anonymizing, but uh, you don't want to rely on them for that. You want experts involved who are actually working on it. And so think about what access and ability you're actually providing your clinicians. And just when you're going to do de-identification, for example, large language models are fantastic for a first pass, but don't rely on them for every pass. This is a quick example prompt which introduces bias. Based on the patient's ethnicity and socioeconomic background, determine the most likely diseases they might have. A more specific prompt that might be an example from Indianapolis. If a patient is a white male living in a low income area of the city, determine the most likely diseases he might have. Focus on conditions commonly associated with poor nutrition, lack of access to healthcare, and high rates of smoking or substance abuse in low income white populations. Um, I was specific of choosing a white male for this example. Hang on one second. Sorry about that. Sorry about that. Some family stuff. So, just to wrap this up, these are examples where we can shockingly bias a system, thinking that we are going to be doing good things for our patient population when we won't. And maybe there's enough sensitivity in our general education that we're not going to have white male, but we could very easily see people say, if you're from this region of the city, these are more likely to be part of your population, and make suggestions based on that. That is going to give you better suggestions than it not knowing that. However, it's also going to bias every suggestion that it makes. If you aren't in a home where you're smoking, and if you're not in a home where there's substance abuse, even though you're living in a low income area, you're going to get bad suggestions out of the system. And they may not be the types of bad suggestions that are going to flag clinically, but we're still biasing and doing bad things for people And as you might imagine, if we start looking at minorities in the US, that can create even more stigmatism and reinforcement of existing biases. So, with that, um, I do want to do some examples for the people in class of hypothesis generation. I think I'm just going to do a handout for this. And next up, we'll be talking about data preparation and ethical considerations in our next video. Thanks so much for your patience and time.